let's talk about sperm and semen evaluation. So why would we collect a semen sample? What's the purpose of collection of semen sample? It's not always necessarily just to check the sperm concentration, and the way the sperm actually looks, but we might also be looking for things like infection, like cancer, etc. Most often, though, in clinic, you'd be checking a sperm count or sperm morphology or just acquiring a sample in order to send it away prior to artificial insemination. So the sample, so the ejaculate composite, has three components to it. It has pre-sperm, sperm-rich, and the prostatic fraction. The pre-sperm is a sperm-free part of the sample, typically sperm-free, or very, 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 very low sperm counts. It tends to be a cloudy secretion. The second, the sperm-rich, is pretty self-explanatory. It is rich in sperm, and it's thick and cloudy. And the prostatic fraction is poor in sperm counts, but excessive in volume. So when we're looking at specific species, we will collect the samples differently. For bulls, rams, and bucks, bucks being a male goat, we'll collect all three portions for analysis. For dogs, stallions, and boars, we'll collect the prostatic fraction, so the third part, separately. So why would we not collect all three samples for dogs, stallions, and boars? We'll have a look at that in a minute. So for dogs, stallions, and boars, evaluate the pre-sperm and sperm-rich portions together. Again, we're leaving out that high-volume prostatic wash. This is an overall generalization of the volumes of ejaculate for each of the species. So we can see boars, stallions, and dogs have the highest volume. However, looking again at dogs, stallions, and boars, we have low concentration of sperm. So for that reason, we know that the prostatic wash is very high in volume, but it yields their samples in general yield a very low sperm count for their species in general. So that being said, when collecting for dogs, stallions, and boars, the individual would tend to only collect the pre-sperm and sperm-rich portions and omit the prostatic wash as to not further dilute the sample. So the volume is high, but the concentration is low. So we're going to omit a lot of that volume and thus reduce the chance of dilution of the sample. There are different ways for sample collection, and it depends sort of what species you're working with as to which one you might be introduced to in your career, if any at all. There's manual manipulation, artificial vagina, electroejaculation, and I won't go into too much detail about these because a group project will probably talk about them in regard to artificial insemination. Manual manipulation using an artificial vagina, so this is an artificial vagina attached to the dog's penis with a collection tube underneath, is quite common for dogs as well as bulls and horses too. So likewise here we have a teaser. So it smells and is supposed to look similar to a cow. And then an artificial vagina is applied with a collection tube on the end, and the semen sample is taken in the collection tube. Lastly, we have electroejaculation, and I do have videos on this PowerPoint about electroejaculation, so I'll let you look at those in your own time. So this is placed in the rectum of the animal, and it's an electrical impulse that stimulates the prostate and stimulates the musculature to create an ejaculatory effect on bulls. Most often it's typically used in bulls. I'm sure it's used in other large animal. However, you do not use this in stallions, ever. They cannot handle the electroejaculation, so don't ever, if you see this being used in stallions, it's not recommended, it's advised against. It is also commonly used in wildlife or exotic species, especially in regard to reintroduction programs. If they can't acquire a normal ejaculatory sample from a species in particular, then they might anesthetize or sedate an exotic or wildlife species, have that animal undergo electroejaculation so that they can get a sperm sample from that animal. So again, just reminding you as well, so the reason that we acquire semen samples isn't always just to check for sperm count and sperm motility and sperm morphology. There are other reasons too. So on intact animals, it might be required to get a sperm sample, get a semen sample in order to check for prostate cancer cells, in order to check for an infection or inflammatory response. So here are some videos if you'd like to have a look at them. It's the artificial vagina and the electroejaculation. We'll move on though to assessment criteria. Oh, no, that's fine. I'll stay here. Okay, so looking at assessment criteria, we're going to look at volume, color, motility, morphology, and concentration of the semen sample. Color, normal would be milky or creamy samples, indicating a fairly sperm-rich sample. You may see green, which would indicate purulence, so purulence in the descriptive term, i.e. white blood cells present. Yellow could be urine, so urine staining from the urethra, or in cows, in bulls, it's common to have yellow sperm sample or semen samples because of increased riboflavin. Red could be trauma to the penis or trauma to the prostate, and that could be red or brown. And clear samples are the least ideal samples in regard to artificial insemination, because clear samples typically refer to a low sperm count. So that's called azoospermia, a lack of or no sperm present. So we'll move on to motility. I hope everybody has seen the Simpsons episode where Homer Simpson has these funny little sperm and they're bumping heads, and then Smithers has perfectly uniform, sort of military type sperm. Ideally, you won't be seeing these if you're ever looking at sperm. Okay, so motility, we're looking at a couple of things. We're looking at the overall activity of the sample, and we're also looking at progressive motility of the sperm. So wave motility is looking at overall swirling motion of the sample. We put it on a microscope slide at 40 power, and just looking for a grading system is fairly subjective. To be given the grade of very good, good, fair, or poor. And again, it's just looking at the overall sample, how many of the sperm are actually just waving and moving in general. There's a lot that can affect motility. pH changes is really, really important and can affect motility. Temperature changes, rough handling of the sample, there's a lot. It's just incredibly, incredibly sensitive, the sperm themselves. So that being said, when a sperm sample is being collected, one needs to make sure that there are not going to be any changes in temperature. Ideally, everything should stay at about 37 degrees Celsius. So that includes the artificial vagina if being used, the collection cup or collection tube if being used. Likewise, when looking at the samples for labs that perform a lot of sperm analysis, they'll have microscope slide warmers, and they can actually buy stage warmers as well for the microscope. Likewise, pH is really important. So if, again, using an artificial vagina or any sort of ejaculatory device, in the collection portion, it's really important to know that, or it's important to ensure that disinfectants aren't residual in the collection portion. So no changes in pH, no disinfections, agents, just nothing added to the sample, either on purpose or by mistake, that could change its pH, because all that can result in decreased motility of sperm, which is a very costly tech error. So with wave motility and progressive motility as well, when you're looking at a sample, it's important to note that a decreased concentration, so a dilute sample will result in a decreased wave motion. Okay, so again, looking at those specific species where we do not collect the prostatic wash because it dilutes the sample, it's for this reason. It's because when we're looking at the sample overall, If we have a diluted sample with that prostatic wash, we're going to get a decreased wave motility and potentially decreased progressive motility due to dilution. So progressive motility is a little bit more specific. You can look at it on about 20 power if you have it on your microscope, or 40 or 10. And you'll add a small amount of saline, so you'll just dilute the sample ever so slightly with warmed physiological saline. And essentially what you'll do is look at 10 different fields and get an idea of the percentage of sperm that's moving progressively, i.e., the sperm is not doing circles, the sperm is not just butting heads with the sperm beside it, but the sperm is actively moving across the little viewing area. It has a direction, it has a purpose, it's going somewhere. So that overall, looking at those sperms, so how many of those sperms are actually going somewhere, they're headed to work, they got a job to do. Get a percentage of them for each of those 10 fields. And then based on your percentages, we're going to give them a rating of very good, good, fair, poor. Very good is 80 to 100% progressive motility. Good is 60 to 80% progressive motility. Fair is 40 to 60. Poor is 20 to 40. And every animal species has different requirements for what is a bare minimum of progressive motility in order for that sample to be used for artificial insemination. So breeding soundness exam, the exam that's performed on the animal and then on the semen samples to identify the level of progressive motility, morphology, etc. So in the breeding soundness exam, bulls need more than 30% progressive motility of their sperm in order to be considered for breeding, or for artificial insemination or breeding. Stallions need greater than 60%. Dogs need greater than 70%, and then humans, just in case you're wondering, we're at the bare minimum. We're at 50%. So we got pretty low standards apparently. But those are the bare minimums, those are the ideal standards in order for these animals to be used for breeding. I think that's all I was going to say about that. Now, that being said, that's right. All of this is relatively subjective, just like our 1+, 2+, 3+ system for quantification. It's all dependent on the ability of the technician looking at the slide, how comfortable they are with identifying progressive motility, how experienced they are, etc. Likewise, other factors can come into play, like the pH, like the temperature, etc., but it can be a little bit subjective. The more experience the individual has, the better, and the more accurate their progressive motility ratios are, or their counts are. Okay, so looking at our normal morphology of sperm. Now, sometimes when sperm is sent to the labs, when semen samples are sent to the labs, they might be stained on the microscope slide in order to look at specific morphology differences. And if they're stained, they're typically stained using eosin-nigrosin stain. And I'll show you some pictures of eosin-nigrosin staining sperm. So looking at our various morphology, I know we learned this in anatomy. The head is where the DNA is contained, the genetic information, it's the most important part. It also contains the enzymes needed to penetrate the egg. The midpiece is where the energy comes from, the mitochondria, helps fuel the tail, and the tail is, of course, the flagella to allow for motility. Now, before I go on to morphology fully, I just want to go back ever so slightly and show you a couple videos in regard to progressive motility. So this one's on YouTube, and this is the information. Oh, drop that. What are you eating? Little gross. I'll be right back. This is why one day my dog is going to have a foreign body surgery, because she just ate a giant piece of rubber. Brat. Anyways, this is a sample just identifying sperm motility, and the music is phenomenal. So if you can sort of slow it down or find a spot, I'll post this video probably to CLP as well. But when it slows down a little bit, you're able to actually see the sperm moving in one direction. So it's quite quick in this video, but when there's an area, maybe I'll try it back here, where you can, if you keep your eye on one sperm, the idea is to watch it shoot across the screen. So one sperm starts up in the corner and then works its way down and through across the screen. That is progressive motility. Okay, these guys obviously got stuck on an epithelial cell, big clump in the middle. But again, you're looking for progressive motility, or the sperm going across the screen. They have somewhere to go, they have a job. They got business to do. This one is super cool. This is a motility analysis system that's available for animals as well as humans. And you put the sperm in on the slide and it tracks their motility. It actually tracks their patterns. So it helps highlight progressive motility versus abnormal motility.
You can stop, you can move forwards and back, how the sperm follows the tracks. You can stop, you can move forwards and back. Right click in the image and select Immotile Track Editor. You see the first Immotile track and you have the possibility to delete it. Next Immotile track and then the last Immotile track. Here you can look at the tracks. We have a track image for each recording.
And it's just really neat. So then it's identifying the various tracks of the sperm, and then it's actually highlighting immotile sperm. So it's highlighting the number of immotile sperm, and then of course it would give ratios of sperm motility is identified here, and progressive, mobile, and then immobile, etc. So it's pretty amazing. Of course, it's taking away from the hands-on tech aspect of it, but it's really neat that technology could allow for that. Here's just another video of motility. This is human, of course. But just keep your eye on one sperm as it's going through and try to track where it's going. Progressive motility is when it's continuously moving through a field, again, going to work. It's got a place to go. It's trying to find that egg. Okay, those that are just jittering or swirling in circles, that's non-progressive motility. Like this guy. What's he doing? Oh, he's gone. So just, it's kind of neat to see it on the screen and sort of track the sperm and where they go. This one I just wanted to show you because I wish I had a green screen.
Next,
this is what I would do.
Motility. How fast the sperm are moving. Are they moving straight, in a straight line, heading for that egg? Or are they swimming slowly, in circles, not getting anywhere? Lastly, are they dead and not moving at all?
Okay, so just another breakdown of sperm motility. And that was all I was going to show you. Okay, so moving on to morphology. I'll put some of those videos on the CLP website as well, or the CLP YouTube channel, so that you can have a look at them. So, morphology. We break morphology down into abnormalities of the head, midpiece, and tail. Common morphology abnormalities in the head would be double head, small head, large head, pear-shaped head, elongated head, and round head, all of which create complications in the, I can't think of the word, in the connection of the sperm into the egg. Likewise, the head abnormalities can also result in abnormalities of motility. And then we have midpiece abnormalities. We have swollen midpiece, coiled midpiece and tail, bent midpiece, double midpiece, and abaxial midpiece. Abaxial midpiece, it's not overly easy to see, but it's when the midpiece is not directly at the center of the head. So it's shifted off ever so slightly. And then the tail, as you can imagine, the tail, main abnormalities with the tail, they're going to significantly reduce the ratio of progressive motility. So if a sperm has a bent tail, coiled tail, is missing a tail, they're not going to be able to get anywhere. So we have a tailless head, we have a headless tail, we have distal protoplasmic droplet. Now protoplasmic droplets, there's some debate about them, but they're often called cytoplasmic droplets as well. And what they are they show up as sort of just ever so slightly refractile droplets on the midpiece tail or the tail. And they are residual cytoplasm from the germ cell. So from the initial sex cell, the germ cell, when the germ cell is shifting into sperm, when it's becoming designated as sperm in the seminiferous tubules, the Sertoli cells are nourishing the little germ cells, and then they're phagocytizing the cytoplasm of the germ cell to eventually result in just a sperm. Okay, so the Sertoli cells are known as nurse cells in the sperm world because they nourish the little baby germ cells, the little baby sperm cells, and then of course they phagocytize the cytoplasm and we're left with simply sperm. So these protoplasmic or cytoplasmic droplets are essentially a piece of residual cytoplasm of the germ cell, of the initial sex cell. And they can interfere with implantation. That's the word I was looking for before. They could interfere with implantation if they're in the proximal area, so hanging out on the midpiece. And they can affect motility. However, there are debates about how much motility is actually affected by protoplasmic droplets or cytoplasmic droplets, and whether or not they're a bad thing or they're just a subclinical finding. And then we have a bent or coiled tail. So this is a bull sperm sample. This one is stained with eosin nigrosin staining, so it helps highlight the sperm. No, actually, sorry, in fact, this one's not. I'll show you one that is. So there is a bent coiled tail in all these little sperm. Here's the eosin nigrosin stain. Sorry about that. Okay, so normal bovine sperm, again, stained with eosin nigrosin stain. And here is some abnormal sperm. So we've got, again, bent tails. Okay, bent coiled tails. This looks like it has a swollen midpiece. And then we have a misshaped head, a loose tail with a droplet in the loop, a loose head. That's the eosin nigrosin stain again. There's a tightly coiled tail. And here we have various abnormalities. So coiled tails, bent tails, droplet, okay, swelling of the midpiece. So various abnormalities. So looking for concentration, we would use this little tool called the WBC Unipet. And that Unipet system involves the use of a hemocytometer. And we count the number of sperm in central large square of the hemocytometer, and we multiply it by 1 million. That number that we acquire is the total sperm per mil in a sample. Oligospermia is a low concentration of sperm. And don't forget, azoospermia is extremely low or non-existent sperm in the sample. So this is our little Unipet system. This is, in fact, is the hemocytometer. We used to use them a lot for counting white blood cells in animals before we had all the blood analyzers. And now they're used commonly in reptile and avian blood because of the nucleated red blood cells. The analyzers don't read it, aren't able to distinguish red and white blood cells apart. So it's this tiny little glass slide. It's about almost the same size as the stage of your microscope. And you'll apply your sample, your diluted with warm saline sample, to the hemocytometer. And in each of these areas, there are grids. So there are grids of 9 squares, which have numerous tiny squares within them. So then you would identify on your hemocytometer the ideal counting area, which is the middle grid. And this is what it would look like under the microscope. Okay, so in this grid, you would count the total number of sperm that are within the grid and count by using their heads. See how with the blue stars here, we can't actually see their heads, they're outside of the grid. So just to ensure accuracy and sort of repeatability of your concentration counting, always choose to count the heads of the sperm. So in this sample, we have 29 sperm in the hemocytometer counting area. Our math would say we would multiply that by 1 million to acquire our sperm per mil. So that dog had 29 million sperm per mil, and the average for the dog is about 100 to 500 sperm per mil. So that dog has low sperm count, oligospermia. And then to find out how many sperm are in the entire volume of the ejaculate sample, you would multiply the sperm per milliliter by the total milliliters involved in the ejaculate sample. And that is semen evaluation. Lastly, so this is what I wanted to show you, doesn't have to do with the semen evaluation at all. I just thought this was really cool. I didn't know that you could buy smartphone tools that attach to your microscope to take perfect microscope pictures. So if any of you hear of this and investigate it and buy one, let me know. I'm pretty darn excited that this exists. So I just thought I would point that out because it's kind of cool. That is it.